So then, please proceed with the discussion.
Thank you very much for inviting me to this excellent occasion. It's such an honor for my company. First and foremost, it was really interesting to see the data that was presented by GI Innovation, and I think it's better for us to carry out our discussion based on the presentation materials. I think all of you who are here today would be interested in NK cell therapy, and I'm sure you're here and having your interest in NK cell therapy. And I want to ask a few questions for CEO Chang, and then as he answers my questions, we will be able to broaden the horizon of our thoughts. So first and foremost, I want to ask one question. You showed us many different pipelines. There's autologs, and then we what we do is we extract glucophilus from the cancer cells, and then develop that into a therapy. And one of the challenging questions that we get from IR sessions is that if you think about Fate or many different companies in the U.S. that are focusing on immunotherapy, IPS or allergenic or core blood origin NK, they utilize these AKs and then try to pioneer and have market positioning. But then they ask, why do you want to focus on autologous? What's the reason why you would like to, stick to this plan? And I think CEO Kim, no, I'm sorry, the Discovery part head Kim showed us a great path about why that they are focusing on autologous. And I think it's time for us to think about whether we should just stick to autologous or switch back to allergen. What do you think is a better approach? What is wiser?
Thank you, Dr. Lee and Professor. It is a great honor to be here with you. So, this key idea, especially for IO, many therapeutic and pharmaceutical companies are paying a lot of attention and they're agonizing over this issue. And there are some other companies, they're thinking of how to develop healthy allergenic and NK cell and how they can freeze that and administer that to patients. And we were between autogenic and allergenic therapy. And for this directly extracting that from people, and it can decrease side effects, and we can use that directly. And there are rare diseases and highly difficult to cure diseases, and we have to secure cells and proliferate that and use it as treatment. But there are cases when patients have to go through radioactive therapy or chemotherapy. So there are patients that have so little NK cells. So we have to get healthy donors NK cells and proliferate them and inject that. So in the future, so NK cells from healthy donors, how well they will match with patient cells is a thing, and markers among various markers, allergenic cells, and freeze them. And through clinical studies, we figure out the best suitable allergenic characteristics to increase clinical efficacy. And we have to keep working on that research, and also Kaikane among other ideas will gain attention, but the problem is the cost. Those disadvantaged people, if they do not get NK cells, and if wealthy people get treatment, then that is also another disaster. And specifically, one another challenge is that there was a paper from Nature. There are transferable cancer cells, and it is the NK cells that can mitigate that. And steady cells, if they get unfrozen, then it can increase cancer cells. So that also gained a lot of attention. And maybe because of time limits, I may not cover that. But nowadays, cancer is not, we are not living in an era of treating it. We are living in an era to prevent cancer. So before you get cancer, you have to prevent it. And if there are dormant cancer cells that can be transferred, then we have to keep mitigating and suppressing it. So you have to bank your healthy cells, and later on, maybe you can inject that to your own body. And if you are older, then maybe you may get healthy and young donors cells. Because if you get older, the higher the risk that you will get cancer. And for that, probably a genetically engineered NK cell, there are a lot of hurdles. Those non-patients or those people who got cancer, I'm not sure if there will be some donors. So let's say, not sure, from 10 million Korean won to 50 million Korean won if we could offer this healthy NK cell. And there will be a market, there will be demand. So for those people who have potential of getting cancer, they may be customers. So we are also thinking of that, and also allergenic. And nowadays, we recently succeeded in 50 embryonic, and recently we're working on 200 dose as well. So that is my answer. Thank you.
Yes, to be honest, this question is very similar to do you prefer your mom or do you prefer your dad? Because there are pros and cons depending on which option you choose. And there are people who want to make therapeutics utilizing NK cells, and this is basically our homework for everyone. And as scientific technologies are being developed over time, maybe there will be a joint solution for people who are facing individual challenges. And this scientific development will be fed to our dilemma. So, if you are interested in investing in this area, you need to do a deep dive research and study for you to understand. And you might think that there's a challenge, and you might think that all you need to do is to resolve this issue, but that is not the case. We will be facing another round of challenges even after we resolve this issue. And what we do is we screen all the papers and scientific research all around the world, and so far, NK was not considered very promising compared to CAR T or other technological options. But recently, the reason why it is getting attention back from the industry or people is because a check parameter was included in cancer therapy, and the margin for NK cell has been growing because of that very factor. And instead of just using NK cell, you're going to treat cancer. This idea itself could be too ambitious. But because we have more options and because we know better about cancers, there are, it seems like hurdles are being cleared away from our site, and I think a great result will be driven later. I'll also mention this, and I present a material for my company, but when we develop NK cell based therapy, it's not about we're going to kill the cancers just using NK cells. We're going to use diverse options, and then NK cell therapy could be a very efficient way of treating the cancer cells as well. This is our joint homework, and I think what's important from CEO Chang's point is that we need to consider costs. We have to understand how we're going to set the price range for this therapy so that more patients can benefit from the new developed therapeutic approach. In that sense, whether autolog is better or allergens better. We need to think about that from the cost perspective. And because we have many different developing technologies that can increase the efficacy, and especially the ones who are focusing on stem cells therapy, what you do is you extract healthy stem cells when you're young, and then as you develop cancer, when you're older, you can develop therapeutics from your young self stem cells, and that could be an idea too. And that at that point, whether iPSC, NK cell autologs or allergen, we don't even have to choose these options. Maybe you can extract a little bit of cell from autologs, and then we will be able to be equipped with a technology to use that little amount of cells. And I think more options will come in the future for everyone. And let me ask then another question for you. GI innovation presentation covered that some of the practical challenges when it comes to production and manufacture. It's really hard to compare individual manufacturers' capacities or production methods. But GI use is feeder cells to expand NK cells. But what happens in reality is that there are variables when it comes to using feeder cells, and so many complicated scenarios happen, and autoimmune system could meet some challenges and hurdles as well, and that is why so many people are using feeder cell free culture system. They're focusing on R&D projects in this regard. But then what happens is that whenever there's cancer or viral infection, NK cell recognizes those and then it gets activated. And that is why we're using feeder cells, because feeder cells are very basically cancer cells. And in order to avoid this step or process, many different technologies are being born, but it seems that you are also trying to avoid feeder cells, the use of feeder cells. And as scientists ourselves, if you think about physiology, NK cells have to recognize some cells, for example, cancer cells, so that it can recognize and try to attack those cells. And that mechanism has to be activated. And when you are trying to eliminate feeder cells, do you have any theoretical background or any way to break have a breakthrough? Can you introduce some of the mechanism, please?
Thank you. Probably that question will be the most significant question for today. And in terms of feeder cell, we have thought about how we're going to use it. And this is something that I covered at the last part of my first question. And in the future, there will be time era where healthy people get injected of healthy NK cells. So we have to decrease the manufacturing processes, and there are exosomes and other genes or other content should be included in the cell. And of course, that technology is very good in terms of conventional technology. And if we thought about effective proliferation ways, and we IPS, and we use peripheral blood, and we tried proliferating it, and it stopped at 100-fold or 160-fold. And that level doesn't meet the commercialization level. So that is why we used IPCC, even though we know that it is risky, and we came up with that. And we proliferate that without patients, and we developed the platform and tried various NC proteins and by antibody and cytokines, among other combinations, and came up with the most effective way to proliferate it, both in vitro and in vitro, and to find out the best combination. And dual body and cytokine platform, and if we make that, we conducted 50 times and 100 times of experiments and the NK cell derived from healthy people, and it proliferated to 12,000 or 13,000 folds, and we kept continuing a 50-meter proliferation, and 130 buyer was produced, and even if we continued freezing it and melting it for 30 times, then it was kept its healthy status. So in preparation for the future, if there is no feeder, then that will have more advantage. But for cancer patients, the PIVO delivering NK cells, if that is used, that is rather even more effective, and it can kill cancer cells. So our company's way is to better prepare for the future. So not only in Korea, but including overseas cases, if we increase that by 13,000 fold, then it is very successful. So whenever you visit our factory, then I'll be happy to show you.
Yeah, I think time is almost up. There are issues that are discussed in the industry, and they are all linked to approval and also costs. So I have to make sure that our therapy is cost effective and also safe. No matter how many times we say it is safe, if we fail to persuade the Korean FDA, then it's all meaningless endeavor. As a result, we need to be able to have some evidence to persuade and convince KFDA. And now I think I can feel we need to have this pioneering spirits to challenge ourselves to overcome the hurdles that are present in front of us. And for other companies who are pursuing NK cell therapy, and you're definitely a leader in the market. Maybe I can go to the final question of today's session. A recent article in Nature said NK cells are actually putting tumor cells in sleep. They put tumor cells to sleep, which can invoke future challenges or risks in the future. But that's more of a physiological status. When it comes to therapeutics, it is a different story. GINO1, this material is going to be combined in order to target the problem. But then the problem is NK cells' strength, the virtue of NK cell is safety. Compared to any other cell therapeutics, NK cell is the most safest form. But if you increase this, if you combine these two, then there is a side effect that might arise in the future. So can you share a little bit about this?
So we used SafeIL2, which is safely approved, and it decreased the weight or when we conducted mice or monkey experiments. And as I mentioned, GI101 it increases TI cells, and there in terms of that, NK cell significantly increased compared to the control group, and so we currently developed it and under development. And the key is that, as you said, T cell has to moderately increase an NK cell. And why do we need a CD cell? Is that it has a memory characteristics. For example, if we use compound treatment, then it is very effective, and it creates a lot of antibody. But for CDC cell, it creates moderate level. So we target those treatments, and thanks. The key is the memory function. Thank you. If we keep talking about this, probably we can talk all night. But these ideas are key issues that we are keep thinking of, and so I gave you this question just to bring this up. So please pay your continuous attention. And if there is anyone engaged in the media outlet, if there is someone who would like to know about us, my company or GI Innovation, if you contact our companies, then if you provide us an opportunity to further elaborate. But of course, any investor here are welcome as well. Thank you for listening. Thank